Dusky iron sleeps in dark abodes, extracting metals from ores. In context, key figures: Anatolian metalworkers circa 2000 BCE. Before, circa 5000 BCE, evidence of the deliberate extraction of copper from ore from sites in Eastern Europe and Iran. Circa 4000 BCE. Copper axes cast in the Balkans show that the technology is known for metals to be melted and shaped. After circa 400 BCE, Indian metalworkers invent a smelting method that bonds carbon to wrought iron, producing steel. Circa 12th century CE, the first blast furnaces in the West are built in Düsseldorf, Switzerland. The discovery of metal extraction was a pivotal advance in technology, enabling tools and other items such as jewelry to be produced by metalworking. The first metals used were copper, silver, and gold, which are found naturally in their metallic or native states. Most other metals are found in combination with other materials as part of a rocky ore. Separating metals from their ores, a process known as smelting, requires high temperatures. Gold and iron at the present day, as in ancient times, are the rulers of this world. William Whewell. Lecture on the Process of Art and Science, published in 1851. Extracting copper. The first people to ever discover the smelting process were most likely potters experimenting with new techniques for firing their ceramics and observing a shiny rivulet of molten metal trickling out from the kiln. Smelting copper requires heating the ore to temperatures of over 1,800 degrees Fahrenheit or 980 degrees Celsius. Not an easy task with an open wood fire, but achievable in a kiln. Shafts for excavating copper ore dating back around 6,000 years have been identified in the Balkans and on the Sinai Peninsula in Egypt. A major challenge for early miners was breaking open rocks to get at the ore. One of the first great advances in mining technology was fire setting. This involved first heating the rock to make it expand and then dousing it with cold water, causing it to contract and break open. Crucibles, or clay vessels that withstood high temperatures and were used to melt minerals, including metals, were found near the mines, indicating that smelting of the ore also took place at the site. Alloys. Copper itself is a relatively soft metal with limited usefulness for toolmaking. The discovery that mixing or alloying copper with other materials produced a stronger metal came around 5,000 years ago. Many of the early attempts to produce copper involved heating copper sulfide ores in the presence of red-hot charcoal, a process that produced copper alloys. These alloys contained arsenic and were much stronger than pure copper. The first copper-tin alloys, probably resulted in a tin containing ore, was present during smelting. The addition of tin to copper made an alloy much harder than either metal alone, which was also easier to cast. This alloy was named bronze. Made from about 3000 BCE onward in the Tigris-Euphrates Delta of Mesopotamia, this useful new metal spread widely through trade, heralding the onset of the Bronze Age. Any old iron. The extraction of iron from its ore was likely first accomplished accidentally in copper smelting furnaces around 2000 BCE in Anatolia, in present-day Turkey. Smelting iron required the use of charcoal for fuel, which burns at a hotter temperature than wood and reacts chemically to remove some of the impurities from the iron ore. The invention of bellows allowed air, therefore oxygen, to be pumped into the furnace, making higher temperatures more achievable. These ancient furnaces, known as slack pits or bloomer furnaces, could not achieve the temperatures needed to melt iron. Rather, they produced a bloom, a mix of almost pure iron and other materials that was then refined by repeated heating and hammering. Iron made in this way is known as wrought iron. Iron is the fourth most common element on Earth and easier to obtain in large quantities than copper and tin. Between 1200 and 1000 BCE, knowledge of ironworking and trade in iron objects, particularly agricultural tools and weapons, spread rapidly across the Mediterranean and Near East regions. In China, blast furnaces were developed which made production more efficient. The blast furnace. Used for smelting metals such as iron, the blast furnace's fuel and ore continually fed into the top of the furnace while air is blown or blasted into the bottom of the chamber, ensuring a supply of oxygen. Chemical reactions take place throughout the chamber, resulting in the production of molten metal and slag, which is removed from the bottom, and flue gases that escape from the top. By the 5th century before Christ, cast iron tools were widespread in China, indicating that blast furnace technology was firmly established throughout the region at this time. These furnaces had clay walls and used phosphorus-rich minerals as a flux to lower the melting point of the metal. In the 1st century, Chinese engineer Du Shi developed water wheels to power piston bellows, saving labor and increasing the effectiveness of these blast furnaces. In Europe at this time, iron production was limited to bloomeries, producing wrought iron.